Next morning at Dr. Samira's studio.
Good morning, Dr. Samira.
Morning, Amelia.
Dr. Samira snapped her finger and a robot brought Amelia breakfast.
Oh wow. Thanks, Dr. Samira. Delicious.
Amelia gulped down the last of the sandwich.
You are late.
I thought class starts at 7:30.
Class does. But this is an internship. You're not here to learn facts, but rather life skills.
I didn't know. I'll do better next time.
With that attitude, I have no doubt, since you are growing on me, I'll let you in on a few important life lessons. If you want to win in the game of life, start your day before the competition, stay afterwards. Work hard, smart, and always know more than they do. And if you don't know more than they do, study until you do?
Yes, ma'am.
Amelia saw Dr. Samira is working on her new invention.
That is so cool.
Would you like to see how it works?
Amelia nodded vigorously.
Electrical energy. Electrical energy gets its name from the word electrons. Electrical energy is the energy of flowing electrons. The two types of electrical energy are static electricity and current electricity. We are going to focus on current electricity today.
Sounds interesting. My dad has taught me some things about that. He's an electrician.
Excellent. Then let's see what you already know.
Amelia racked her brains to remember.
Well, Dad always said our house uses electrical energy or electricity to run all the devices and appliances. But you have to be careful when working with electricity. Ouch. Because you can be electrocuted.
That's a solid foundation, and he's not wrong about the safety part. Current electricity requires a circuit to do its work. A circuit is a complete path for electrons to flow. Without a complete circuit, electrical energy stops working. The lights turn off. The invention will not work. Got it? Now, come with me. This is a circuit. The basic parts are battery or a power source, insulated wires, and a load, a thing that uses the electrical energy. The insulated wires have to form a complete path, from the negative side of the battery, to the load, and then back to the opposite side of the battery. If it does not make a complete path, it will not work.
She disconnected the wires from the battery and the light bulb turned off.
Now you try. You see that the wire has to be touching. Any holes or breaks and the load turns off.
I see it.
That's an incomplete circuit.
Meaning, there is a hole somewhere that is stopping the electrons from flowing.
Amelia put the wire back touching the battery and the light bulb turned on.
Now it's a complete circuit. That means the electrons can flow from the negative side of the battery around the path to the other side of the battery.
You know, I was going to wait to show you this next topic, but seeing as though you've learned so quickly, let's try it now.
Amelia smiled proudly.
I'm ready.
We have made a circuit with one path for the electrons to flow, but what happens when one light bulb goes out?
I'm not sure.
Dr. Samira unscrewed the light bulb and the other bulb turned off.
They go out. There are two types of circuits: series and parallel. The only difference between them is the number of paths that each has. But the consequences are huge.
Amelia quickly wrote notes on her tablet.
The series circuit has one path.
Dr. Samira continued.
Just like the one we've been looking at.
Yes. And what did we say happens when one light bulb goes out on a series circuit?
If one light bulb goes out, the rest will go out as well.
Common examples of devices that use series circuits are Christmas tree lights. But I do not use this kind of circuit in my inventions.
Dr. Samira moved to another table, where an even more complex circuit had been assembled.
So is this a parallel circuit?
That's right.
I want to learn how to build this one.
All right. A parallel circuit has two or more paths for electrons to flow.
Dr. Samira said. And then, she marked out each path, with her hand.
The key to study a circuit is to track the path with your hand.
I get it. This circuit has three paths for electrons to flow.
Amelia observed and drew out each path with her hand.
Path 1. Path 2. Path 3.
3 is the right number. And if the light bulb goes out here, what will happen to the rest?
They will steal it. I think the importance of having more than one path for the electrons to flow is that if one light bulb goes out on this path, the light bulbs on other paths will steal it.
Not bad.
What are those?
Amelia asked, pointing to a pile of objects.
Switches. They are important for controlling if the electrons are flowing. In other words, these control if the electricity is on or off. If this switch is up, that means it is open. When the switch is open, it creates a hole or gap so that electrons cannot flow across. Therefore, the lights will turn off. If the switch is down, that means the switch is closed, the gap disappears, and the lights will turn on. Alright, an open switch equals lights off. A closed switch equals lights on.
Dr. Samira placed the switch on the series circuit. She lifted the switch up and the lights turned off. She closed the switch and the lights turned back on.
You can place them anywhere on the circuit, depending on what paths you want to control.
Amelia added switches to each of the paths on the parallel circuit and experimented by opening and closing them. Suddenly the lights in the studio shut off.
That's not supposed to happen.
A robot rolled up from the dark.
Dr. Samiri. The lights were turned off from the outside.
Outside?
Dr. Samira looked perplexed.
That's not accidental.
Cannot be. Do you think they've come?
What's going on?
Just then they heard a loud crash.
Must be. Hurry, Amelia. We need to hide.
They climbed into a tunnel that was concealed beneath a table and crawled for some time. Finally they stopped at a vent that gave them a view of the studio from above. Below they could see figures throwing Dr. Samira's inventions around.
Where is she?
Hissed an angry voice.
Tear this place apart until she is found.